Students, in this video we are going to see about dynamic networks of system interconnect networks. So in the previous video we have seen about the static networks. So what is the difference between static network and dynamic network means? Static network, it is a point-to-point connection between the processors and memories and I/O devices. That connection will not be changed during the execution time. But dynamic network is an opposite of static. So the connection between the processes will be changed or may be changed based on the communication demand at the time of execution. So at the time of program execution, the connections between the processes, between one processor to another processor may change. How we can implement this dynamic network means we are using some taxonomies. First one is using digital bus systems, another one is switch systems, switch connections, and third one is multi-interconnection stage, MIN networks. So like that, and crossbar switches. These are the four different mechanisms of implementing the dynamic networks in a system interconnect network devices. First we will see bus system. What is meant by bus? Bus is nothing but a collection of wires and cables which implements the message passing through two different devices. So bus is generally, it's a collection of wires and connectors which enables the data transfer from one processor to another process. So it enables the data transactions between the processes. So it is a collection of wires and connectors. Okay. So this is the first technology where this dynamic networks is implemented and it started. So a bus system is a collection of wires and connectors, multiple models. Within the multiple models, what are the multiple models means? Processors, memories and peripheral devices, and which connect to the wires data transactions between a pair of models. If you want to transfer two information from one processor to another processor, this digital bus system has a collections of wires and connectors connected between two processors. It enables the data transaction between the two processors. So this is called as bus system. Okay, then bus supports only one transaction at a time. So that's what this bus system is. Maximum it is called as a time sharing bus system and contention bus. Okay, so this kind of digital bus systems are called as contention bus or time sharing bus because it only enables the one transaction at a time. Okay, and many bus standards are available. So we will see the typical bus architecture of dynamic bus system in this layout. So we have connected many processors in the processor 1 to processor n we have connected, and similarly many memories are connected. Along with memories, I/O devices and I/O peripheral devices are there. So how these are connected means using a system bus. So using a centralized bus system bus, these processors, memories and peripheral devices are connected. Okay. So this is a centralized bus system. So in this centralized bus system, if two processors are going to parallelously executing its process means that time, because only one transaction can be enabled in the bus system. So that time what will happen, we cannot achieve the parallelism, and detecting the parallelism in this centralized bus architecture is very difficult. That's what they have one more variation has been made in the system architecture, system bus architecture, in that we can achieve more throughput. Okay, so this is the variation of the previous one. So how we have implemented this means we introduced separate bus system for each processors and its memories. So if you take n number of processors means n number of system buses are arranged. So one system bus is dedicated for one processor. If that processor wants to communicate with the remaining devices, that uses only that system bus 1. Similarly, processor 2 wants to communicate with other devices means it uses system bus 2. Likewise, each dedicated bus system is allocated for processors. Thereby, we can achieve throughput. What is meant by throughput? What is the meaning of throughput means? It is nothing but it is a measure. It is a measure. It is nothing but it is a count of, it is the amount of how many messages can be processed, can be transferred in a network. If you take one networking devices, network throughput is defined as a total number of messages the network can handle per unit time. If you take 1 unit time, how many number of messages that network can be able to transfer, can able to pass. So this is called as network throughput. Okay. So this is called as network throughput. Here in this assembly we can achieve more throughput because each dedicated system bus is allocated for each processor. So this processor can be able to transfer its messages independently. Without the disturbance of other processor, it can communicate with other devices independently. So thereby we can achieve more number of transactions in a per unit time. That's what this assembly achieves more throughput. Okay. Okay. Fine. This is about bus system. Next type of technology what they are using in dynamic network is switch models. We know that our switch is like on or off. It has two inputs and it produces two outputs. Say for example, if you take one typical switch, it has A comma B as inputs and it produces same A comma B outputs where A and B is equal to 2. Okay. So where you can see this examples here. So if you take one binary switch, it has two inputs and produces two outputs, means where A comma B equal to 2. And variations of switches are available, but it will go, if you go with apart from two inputs and two outputs, if you go means how we can select the inputs, means it should be in the 2 to the power of k. Okay. So it should be in the 2 to the power of k. A equal to B equal to 2 to the power of k. Say for example 4 cross 4 switches are available and 8 cross 8 switches are available. 16 cross 6 switches are available. Like that, if you go for more number of inputs switches, means that number of inputs is basically related with 2 to the power of k. Okay, where k is one integer. If you take k equal to 2, means 2 to the power of 2, that implements 4 cross 4 switch, and 2 to the power of 3 it implements 8 cross 8 switch. Like that you can have switch models where at the time of execution, if the processor wants to communicate with other device, means the connection will be established dynamically using switches. Okay, using switches, at the time of execution, program execution, the connection will be made according to the processor's demand, communication demand. Okay, if the processor 1 wants to access the memory 2, means the connection between processor 1 and memory 2 will be established with the switch models. Okay, so that's what it is called as dynamic. There are some 4 variations in the switch models. What are those? Means first one is straight connection. If you take two inputs 0 and 1, it directly passes its messages through 0 and 1. There is no overlapping, there is no bend, and there is no tilde connections, everything and all. It is called as a straight connection. And one more thing, crossover connection. So crossover connection means 0 will be inverted to 1 and 1 will be inverted to 0. Like that you can have crossover assembly of switches. And third one is upper broadcast. Upper broadcast means you will be using only one input, but it is turned as two inputs or two outputs. So either you can use 0 for the upper broadcast, you will be using 0 input, but this message is transferred to both of its output 0 and 1. So that is what it is called as upper broadcast. And lower broadcast, in the sense you will be feeding the input in one input, but it is broadcasted in both outputs 0 and 1. So this is what called as lower broadcast and upper broadcast. So these are the some variations of switch models. Then what is the next one? Multi-stage network, MSN or MIN, multi interconnection network. So what is means use it with the previous one, what we have seen, the switch models and crossbar switches. No, with this assembly we will be creating one multi-stage network. So what is the multi-stage network? It has n number of processes. Similarly, it has n number of models, intermediate models. But this intermediate modules are grouped and it is forming one interconnection, interstage connection ISC, and this will be purely made by switches. So you will see the examples here. So here interstage networks are there are different methods need to change the interconnection pattern so that the given input is sent to the desired output. So here in between the interstage connection you can make n number of patterns, interconnection pattern. Likewise, you can design which input should be passed to which of the output line. So if I want to give the input to processor 1, this processor 1 input should be reflected in processor 3, means I can design. At the time of execution, I can make a connection between the two processor 1 to processor 3, where I will decide my own desired output that should be passed to processor 3. Okay, so that is also possible. How we can achieve, means we can achieve some perfect shuffling methods and exchange operations and some left shift, right shift operations, shifting, shuffling and exchanging. These kind of operations I can design my own interconnection pattern where I will decide my own desired output should go on which line. Okay, so this is called as dynamic networks. So here in dynamic, I will recall it once again. So in dynamic network, what is meant by dynamic network means dynamic networks where the connection between the processors and other devices will be changed during the execution time based on the communication demands. Okay, so there are some three technologies majorly used in dynamic networks. First one is bus system, second one is crossbar system, and third one is multi-stage connections. So first one, bus system. Bus is nothing but it is a collection of wires and connectors that enables the data transfer between two modules. Okay. So here in bus system, first we see the centralized bus system. There are some disadvantages in that. Then we move on to the bus arbitration method where we can achieve more throughputs. And second technology is switch modules, which is a one device which takes two inputs and produces the same output, where A and B should be 2 to the power of K. Okay, likewise we can implement 4x4 switches and 8x8 switches, 16 cross 16 switches. Likewise we can implement more switches here, and there are some variations in the while passing the outputs of the switches. There are 4 variations. First one is straight, crossbar, crossover, third one is upper broadcast, and fourth one is lower broadcast. So this is the second technology. And third technology is multi-stage network, where the interstage connections were made. So with the help of crossbar switches, there I can design my own interconnection pattern to send my input to the desired output. Okay, so these are the different technologies where the dynamic networks is implemented. I hope you understand. I will catch you in the next video about next topic. Thank you.